All right, first we're going to start with estimating scientific notation. So first we have to round these numbers prior to putting them in scientific notation. So the first number we hit that isn't a zero going left to right, okay, going in this direction. The first number we hit, we're going to put a decimal point behind it, and that's where we have to round from. So here is where we're rounding, okay? So 3 and then a 7. A 7 is one of the 5 numbers that do something. So the 5 numbers that do something are 5, 6, 7, 8, and 9. Those are the 5 numbers that actually do something. And the thing they do is make this digit go up 1 number. So this becomes a 4, and everything else behind it turns into zeros. Then we're going to write this in scientific notation. So this is going to be 4 times 10, and then you count how many digits are behind the 4. So 1, 2, 3, 4, 5, 6. So that is 6. All right, and that is scientific notation of this number, estimated. Now we're going to do something very similar over here. Now, the first number we hit is going to be here. So here is where I round from. So the 3 is not one of these numbers, so the 3 does nothing. So this is now just 0.00004. And just everything else I ignore behind it when I round from this direction. So now that it is rounded, I can turn this into scientific notation. So this is where you see where the rounding point is right here. So this is where we're going to write. So we're going to be 4 times 10 to the power of, okay, so how many digits are in front of the 4? Okay, I usually count the movements of the decimal point because that's what's actually happening. You're moving the decimal point. So 4 has a decimal point here, so it would be 1, 2, 3, 4, 5. But if you write the number properly, you could also just count the digits in front of the 4, which is 1, 2, 3, 4, 5. So it's 5 as well. So this is going to be 5, but how can you tell the difference between this creating this and this creating this? This exponent is negative, meaning instead of multiplying by 10 over and over again, it is dividing by 10 over and over again, causing the number to get smaller and smaller and smaller. Okay? So now we're looking at the next one, which is regular scientific notation. So I'm using the same number so you can see the difference. So here, I just stop at the number. I stop at the first number, and that's where the decimal point is going to go. So now it's 3.78, and then the rest of them are 0, so I don't have to write any of that. Times 10 to the power of how many digits are behind the 3? 1, 2, 3, 4, 5, 6. Okay? So that's scientific notation. Here, we stop at the first number. Okay, that's the 4. That's where the new decimal point goes. So it's going to be 4.31 times 10, and then how many digits are in front of it? 1, 2, 3, 4, 5, 6. 6. I guess I added an extra one here. No, in front of the 4. 1, 2, 3, 4, 5. That's 5. Everybody makes mistakes, guys. Or you can count from the new decimal point. 1, 2, 3, 4, 5. It's usually my favorite, but this year everyone's had a really hard time moving the decimal point. They've left the answer looking like this, and that is wrong. This is correct. So let's keep on shifting forward. Now we have to do the opposite. They gave it to me in scientific notation, and now I have to write it. So 6.2, right? We're moving this decimal point 5 times, making this number larger. So we're multiplying it by 10 5 times. So 1, 2, 3, 4, 5. Here's our new decimal point. So 6, 2, and then all of these fill in with zeros. So 1, 2, 3, 4, and there's our new decimal point. Do you have to write this? No, but you cannot give me this answer. This answer has 2 decimal points, which is not a number. Now, this one. So again, we start with 3.1. But now the negative is telling me instead of making the number larger, we're making the number smaller. So we're going to the left. 1, 2, 3, 4. There's my new decimal point. So it's 0.000. Okay, 0.0031. And there we go. I've converted this into standard form. Now here, we're going to do two things. We're going to turn this into scientific notation. This is the way most calculators, the basic ones, would write scientific notation. So this is 4.81 times 10 to the exponent 6. That's what the E stands for. So now I'm going to convert this into standard form. So this would be 4.81, and I'm moving this decimal point 6 times, making it larger every time. So 1, 2, 3, 4, 5, 6. Here's my new decimal point. So my answer is gonna have 4 zeros. So 4, 8, 1, 1, 2, 3, 4. And there we go. Okay? Now I'm going to teach you how to multiply, divide, add, and subtract scientific notation. So multiplying. So when it's multiplying, how do I know it's multiplying? There's a multiplying in the middle between the two scientific notations. So this is going to multiply with this. So the first number is going to multiply with the first number. So they're going to actually multiply because it says multiply in the middle. So it's going to be 1.2 times 7. That's going to be 4, 1, 7 plus 1, 8. There's only one number behind the decimal point, so then one number ends up behind the decimal point. So the answer is 8.4. So I know what the first number is going to be, 8.4. So I'm done with this and done with this. Now I'm multiplying two numbers that have the same base but different exponents. So I know it's still going to be times 10 because we're doing scientific notation. So the 5 and the 3 are going to add, as exponents do when the bases are the same. So 5 plus 3 is 8. And we're done. So now we're going to divide. The first numbers are going to actually divide because it says division in the center. So that is 3.5 divided by 7. So the decimal point is going to go straight up. And now, how many 7s go into 3? None. How many 7s go into 35? 5. So I know that my first number is going to be 0.5. We're still doing times 10. Remember that exponents subtract when you're dividing. So this is going to cause the 7 and the 3 to subtract. So we left with 4. Now, I've completed all the arithmetic, but scientific notation, the first number has to be less than 10, okay, and 1 or greater. So it has to be between these two. It's allowed to be the 1, but it has to be between these. And this is less than 1, which is not allowed. So I'm going to have to move this decimal point back, making it a 5. Or 5 decimal point, if you want to know where the decimal point ended up. So I moved it back. Times 10. So I have to move this number back, causing it to be 3. This is a correct answer. This is not written in scientific notation. Just make sure you know that. Now let's do one that's adding. If you are adding, there is a rule before you can begin. Same rule for subtraction. So if you're adding or subtracting, these two have to be the same before you start. Are they the same? Yes. So then I can begin. 4.1 adds with 1.2, causing it to be 5.3 because I added this and this. I still have times 10 because we're writing something in scientific notation. And then the 4 stays a 4. And that's it. Okay? If everything's set up, adding scientific notation is very, very easy. So let's do this one now, the final one. Now this is going to have a couple extra steps. Why? I'm subtracting, but it doesn't meet the first requirement. Okay, it doesn't meet the first requirement. This has to be the same as this. Okay, so the rule is you always make the smaller one meet the larger one. So we're going to write 1.8 times 10 to the 5, because nothing is changing on the left, but the right is going to change. I have to make this number into a 5. Okay, so I made this number go forward 1, which causes this number, this decimal point, which is right here, every number has a decimal point, this number to move forward 1. So now this number has caused it to turn into 0.3. I know that's not allowed to be in scientific notation, but for right now, this meets the requirement where I'm allowed to add them now. This isn't my final answer. This is just something happening in the step. So now I'm allowed to subtract these. So why am I allowed to subtract these? Because the exponents are the same. So now we're going to do 1.8 minus 0.3, line of the decimal points. I get 5 and a 1, so 1.5. So now I have 1.5 times 10. They're both 5, so it stays 5. And I'm done. And that's how you do scientific notation.